Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. Le webinaire va bientôt commencer. Veuillez rester en ligne. La diffusion vient de démarrer. Tous les participants sont en mode écoute seul.
Good morning, everyone, to this webinar. We'll give it 1 or 2 more minutes so everybody can join, and then we'll start. Okay, good morning, everyone. Welcome to today's webinar on Neo4j 3.4. My name is Alexander, and I'm very happy to have Jim Weber, our chief scientist, here with me today, at least virtually here, who will now in the next 30 minutes or so talk about all the exciting new things and features that Neo4j version 3.4 brings. Just to name a few: improved read and write performance, spatial and daytime data, as well as security features, and as you can see on the slide already, Bloom as well, our new visualization tool. If you have any question during this webinar, please use the questions dashboard that the GoToWebinar panel on your right-hand side on the screen probably offers. We will collect them, and then in the end of the session, if there is time, we try to answer some of them. I think that's enough for me now. Jim, the virtual stage is yours.
Thank you very much, Alex. That's very kind of you. Good morning, good afternoon, good evening, depending on where you folks are. My name is Jim Weber. I'm Neo4j's chief scientist. And just very warm welcome to the webinar today. It's rather an incongruous title, if I'm honest, to have a webinar about effectively a minor release of Neo4j. And I'm impressed that so many of you would register for it, given it's such a prosaic title. But actually, I think despite its rather unimpressive numbering, the Neo4j 3.4 release is actually chock full of some excellent new features that I think will be warmly welcomed into your dev stack. So forgive us, Neo4j is, as you guys all well know, terrible at naming. We're called Neo4j, for heaven's sake. But it turns out that we're also very understated when it comes to numbering, because there's a lot of stuff in here I think you're going to enjoy. So look, Neo4j is evolving as a company. You've known us over the years as the graph database company, and we've been very proud to create that category and pioneer that category. But we also see that there is a broader role for graphs across IT, particularly enterprise IT. So we're now working towards becoming not just a graph database company, although the graph database remains at the center of our universe, but we're transitioning to becoming a graph company, meaning that we will also provide graph viz, graph compute, and a bunch of other things that make graphs help you to deliver amazing systems in your businesses. Our business on the whole is doing pretty well. We're a couple of hundred employees now, so we're definitely punching above our weight there. headquartered in San Mateo in Silicon Valley, but with offices all around the world. We have a global footprint, and today I'm coming to you from our office in central London. We're a private venture-backed company with incredible adoption across the world. 70% of the world's top retailers use us, about half of the world's top financial firms, 80% of the world's top software vendors, including kind of blue chip names like Microsoft, are using us. In our ecosystem, there are close to 1,000 participants in our startup program, close to 300 enterprise customers, 100 partners, almost 55,000 now members of our meetup group, participating in about 500 Neo4j events per year, including this one. So I think it's safe to say that graphs are becoming very widely accepted, both by kind of exalted enterprise users and as well as by a large community of graph advocates. Our vision for the future is to enrich that graph world with Neo4j, the graph database, at the center of it. But we intend for our graph platform to be accepted and used by a variety of users, developers like myself, but equally data scientists and even business users who want to understand the information encoded in their graph data. And our vision is that we'll be able to bring all of this together into a unified graph platform, which has properties of being very easy to use, convenient to use, and being very holistic in terms of each of the components of the graph platform work well with one another. And really what we're targeting is this notion of a connected enterprise, where transactional graphs, the kind of thing that Neo4j, the graph database, currently provides, being at the center of that connected enterprise, also enables use cases around for data science and business users on the AI side around things like segmentation and sentiment analysis. We have some work going on in graphs for machine learning. And on the business-facing side, where we start to present the underlying graph model as visualizations, various visualizations, starting with our graphs themselves, but in the longer term, various visualizations, which will enable business users to access the information encoded in those graphs. And this represents, I think, quite a broadening of Neo4j's viewpoint. So no longer do we just focus on folks like me, and probably many of you on the call, as technical people who interact with a powerful database, but we're trying to bring graphs to a broader church of people who we think will gain value from being able to use graph data. That being said, though, the remainder of, the majority of this talk is about technical innovation in the 3.4 release. So I think that's well worth diving into. But before we do that, I do think it's worth recapping Neo4j 3.3, which was a release from about 6-7 months ago, so the autumn of last year. And I think it provides a good narrative arc for where we're going longer term. So in 3.3, you may recall we released a whole bunch of performance improvements. In the drivers and bolt protocol, we gave the least connected load balancing strategy, so that drivers will automatically route you to an instance of your cluster which will be lowly loaded. We also tweaked the Cypher engine. We created something called a slotted runtime, a vector-oriented runtime, which means that Cypher runs faster and creates less garbage on the JVM, so you get a much more consistent throughput pattern when you're running Neo4j in production. We did a bunch of low-level kernel optimizations in terms of batch generation of IDs and fewer locks whilst preserving safety, as well as moving our page cache metadata off the JVM heap so that we don't antagonize the Java garbage collector again. Thematically, we've been over time moving from Lucene indexes to native graph indexes inside Neo4j, and in 3.3 we did that for numeric indexes. You'll see later on we've also now moved our string indexes out of Lucene and into our own index provider, which actually provides some pretty exciting performance gains. At the storage level, we created a new bulk importer, and we have made a bunch of memory improvements that just mean that Neo4j goes a lot faster. And underneath all of that, we continue to refine the administration surface of Neo4j so that it's easier to run for DBAs and ops folks. So in 3.3, we were really pleased that our transactional write performance made a huge gain, about 50% faster than in 3.2. Meaning that you could, in a realistic scenario, real world load, you could expect to process around 20,000 or so ACID transactions per second on Neo4j 3.3, which is pretty good, right? It's not in the same league as some of those large non-ACID services, so some of those eventually consistent databases, but the ACID guarantees that Neo4j provides means that your data is safe. Once it's in Neo4j, it is durable to disk and safe, and in fact, typically durable to multiple disks and safe. These guarantees, I think, are pretty important. It means that you can reason about the database much more easily. For example, you can do things like read at least your own writes. And so being able to put 20-odd thousand ACID transactions a second through Neo4j is pretty stellar improvement. We also introduced privacy, so secure transit for multi-region clusters. So prior to that, we would expect that the end user would deploy a virtual private network or similar. Now Neo4j itself automatically, should you choose to enable it, encrypts any cluster traffic between regions. So if you're going out over a WAN, you can now configure Neo4j to be secure over that WAN rather than doing an additional opt step yourself. We also introduced the notion of Neo4j Desktop, which is squarely aimed at developers like me, so that we can run Neo4j conveniently on our local workstations. Neo4j Desktop is effectively a mission control for developers. It's completely free. Includes a development license for Neo4j Enterprise, so the most powerful edition of Neo4j, and it will also keep you up to date with the latest versions, plugins. It will allow you to install things like the Graph Algorithms library and the APOC suite of procedures and so on very conveniently, so we don't have to mess around doing copies of jar files around the command line. And it presents it to you in a rather nice interface, so you could be able to work with multiple versions of the database, and indeed multiple databases conveniently on your workstation as you're developing graph apps. In 3.3, we also introduced a bunch of graph algorithms, and these graph algorithms are, in my mind, pretty outstanding. But they do things that you might expect as a graph-oriented person. So we've got algorithms for pathfinding, algorithms for finding centrality, algorithms for finding clusters or communities, and so on. And what's remarkable about these is their sheer performance. These graph algorithms are designed to work on a single machine, albeit a single machine with lots of RAM and many cores if you so wish, but they take advantage of data locality in a machine to process these, to perform these algorithms extremely quickly. For example, we page ranked using this algorithm a large internet payment provider's graph of circa 20 billion items. And we did 10 iterations of that large graph, and it finished in 6 hours. Or maybe actually there was 20 iterations of that large graph, which finished in 6 hours, which just goes to show some of the power that you can exploit if you have data locality. And these algorithms are just phenomenal. They're trivial to call from your Cypher code, and they do a bunch of hard work for you. I'll also point out that you can, using Neo4j clustering, you can even identify particularly large machines in your cluster that you can specialize to run these algorithms if you so choose, so you can monopolize those machines without affecting the general flow of your transactions through the database cluster, which is very convenient and very cool. So at the end of last year then, we had a graph platform that looked a bit like this. At the top, we had the drivers and APIs supported by Bolt and GraphQL. For developers and administrators, we have Neo4j Desktop. We have the APOC library and the graph algorithms. At data integration, we have the Neo4j ETL tool, which with a few points and clicks will enable you to import relational data as graphs from legacy relational systems. And we have the data importer for extremely fast offline ingestion of graphs. Neo4j 3.3 database itself with about 50% faster writes, and we locked down a bunch of security things there. Towards the top right, we have some integration with popular visualization vendors, and in the bottom right, we have graph analytics stuff going on in Spark. So that's the foundation that we're building on. Where are we now? Where are we today? Well, I'm very pleased to say we've actually come quite a long way. Firstly, I'll point out something that's happened very recently, that it's very clear now that market adoption is moving towards graphs. The category of graphs is a thing. All of the big vendors are now in graphs. Neo4j, we're the little big vendor now in graphs. And we see a strong movement towards standardizing on a declarative graph-oriented query language. Neo4j have spearheaded this by donating our Cypher query language to the Open Cypher initiative. And now there is a big call amongst all of the big players and the little players like Neo4j towards a standardized graph query language, which I believe will be based on Cypher. That's now happening out there. Even the famous ISO SQL committee is involved. So I see that on the back of the work done up until Neo4j 3.4, it's very clear that we will subsequently get a graph query language that will be ubiquitous in much the same way that SQL is ubiquitous for relational databases and relational technology at the moment. I think that's an incredibly powerful thing. I think it's going to open up whole avenues of exploration of graph technology for vendors big and small, for users big and small, that Neo4j always envisioned when we created Cypher. So I'm profoundly both proud and optimistic about that future. But inside the product itself, we now have the ability to combine graphs with geospatial data, which I think is extremely interesting. It's very easy to use. So for example, here's a query that allows me to find all coffee shops within 100 meters. So in this case, with using the point function with points, passing in a long lat as a point of interest, matching then a location with a business at a location which is in a particular category, where that category has the name coffee, and the distance is less than 100 meters from my location. Return the location, the point of interest as distance, and the name as coffee shop, and then order by distance in descending. So that will find me the nearest coffee shops within 100 meters of my given long lat. That's pretty nice, right? So you're effectively bringing in a whole different dimension to your graph data and mixing it in super conveniently and super easily with your regular graph matching queries. But you could even do something in the third dimension. So you can do something like beacon-driven shopping. So if you imagine, kind of those Bluetooth beacons or something, you could actually even say something like recommend a shirt available in a store close by the men's department. So you could even do 3D geographies here. So recommend me something on a nearby floor and so on. Very exciting. In terms of scale of the database, we now have a feature called multi-clustering for global apps, where you're able to horizontally partition a domain by country typically, or by product, customer, data center, or what have you, such that each of these clusters, subclusters in the multi-cluster, can operate quasi-independently. Certainly they can all be written to independently to give you a write-load boost. But also it has this lovely secondary effect that, particularly in these days of GDPR, you are able to partition your cluster such that data for particular jurisdictions physically remains in that jurisdiction, while having the ability from the operations and development side to access that cluster through the same mechanisms that we're used to through the drivers and the Neo4j administrative interface and so on. So this is pretty interesting. It's we've talked rather loosely about this on the engineering team as being effectively shared nothing sharding, and it does set us up for the future where we'll be able to, should you choose to, put relationships between some of those shards in some safe way. In terms of outright performance, if you look at where Neo4j 3.2, 3.3, and 3.4 is, we've made some incredible strides in runtime performance for Cypher. And in doing so, because we own the whole database stack from Cypher all the way down to the disks, we are able to investigate and profile where the bottlenecks are. And in profiling, we find that there is one component in the historic Neo4j which consumes about 80% of the transactional write overhead. That component, unsurprisingly, is Lucene. Now, Neo4j has relied on Lucene for indexes since time immemorial, And leucine is a phenomenal piece of kit. There is no getting away from it. As a general purpose indexing toolkit, leucine is amazing. But as a general purpose toolkit, it's not very affined to the kind of ways that we use it in Neo4j. So over time, we've been working to remove leucine, particularly from the hot parts of Neo4j, and replace it with our own graph-affine indexing. So in removing leucine, we've firstly taken label groupings, which you saw in 3.2 if you're paying attention. We moved numeric indexes out of leucine in 3.3, and now we've moved string indexes out of leucine in 3.4. And what we're finding is that our write performance has absolutely rocketed. The data structure we now use is a GB plus tree, which is a variation on a B plus tree designed to handle a high concurrency via an MVCC-like mechanism. And we find that not only can we preserve those cherished acid semantics, but it also provides extremely fast reads, order of magnitude, easily leucine, and incredible writes. So orders of magnitude faster writes than we could do with leucine. So we're pretty pleased about that. Admittedly, it's quite low-level stuff. It's very interesting if you are interested in building databases. But as a user, I hope that when you use 3.4, you'll just find that your throughput soars compared to earlier versions. And in fact, we chart this. So in Neo4j, we run a whole bunch of benchmarks continuously on our commits on a daily basis. And you can see there back in March when we finally merged the native string indexing, that we got about a 3.5 times performance boost right off the bat, which is just super, super pleasing compared to our prior implementations. An average of about 5x improvement. That's just, you know, I'm for once lost for words at just how impactful that can be. It feels like, you know, for years Neo4j has been dragging heavy bricks behind it, and we've just cut the cord to those heavy bricks and zoomed off. It feels very nice to be free of that tyranny. On the ops and admin side, we've now, in addition to the existing quite rich set of ops and admin features, we've now added property blacklisting. And property blacklisting allows you as the administrator to disallow access to certain properties for users in particular roles. So for example, as a payroll user, I may be able to see your salary property, but as a HR user, I may not be able to see your salary. I may only be able to see your HR record, that kind of thing. That's a really nice affordance there. That means that you can start to ascribe quite fine-grained controls over who can see what in your database, which is a welcome change. We've also introduced rolling upgrades. So for example, you will be able to, in a live cluster, upgrade from 3.4 to subsequent versions, for example, the 4.0 in future, without downtime. So you may be running a very large mission critical system, and now you'll be able to continue running that system, assuming there are no store upgrades necessary while you are upgrading that cluster. This, I think, is very important for those of you running 24/7 systems. It's also very important for us on the Neo4j engineering team, because it provides an important foundation for us to be able to build even larger, always on, and therefore always upgrading somewhere kind of clusters. Very exciting. We've also implemented something called cache reheating, which is a mean time to recovery optimization. So imagine you're running a cluster, and your cluster is warm because it's been servicing queries for some hours or weeks. And then because of some hardware failure, you lose one of your cluster instances. When that cluster instance returns, by implication, because it's not running on non-volatile RAM today, the caches are all cold, so that one instance is slower than the others. What we now do is maintain a compressed bitmap of popular pages from that instance. And once the database becomes available on a background thread, we load those popular pages. Effectively, we aggressively fault those pages back into RAM when the database becomes available, which has the effect of preheating your cache to be as it was, or close to as it was, when the machine went down as quickly as possible, rather than lazily doing this on when an application query touches part of the graph. In our testing, again, this means that your database returns to its normal warm and therefore fast state far more quickly than it would have if we relied on queries alone to do that. It also means that for those of you that know some of the hacks on Neo4j, you won't need to run your warm-up queries before you return the database to production. The database takes care of that for you now. So now you've got a much faster restore, which gives you a lower mean time to restoration. And it actually gives you other operational benefits in terms of better cluster behavior. So here's where we are summer 2008 in our, as we are today in terms of the graph platform. We've got a much nicer administrative experience with rolling upgrades. We've got cache warming, improved diagnostics. Our backups are actually a lot better now. And also in clustering, we actually have resumable catch-up when a cluster instance falls behind. We, on the graph compute side, have pre-announced Morpheus for Apache Spark, which is graph analytics in the data lake, progressive analysis using named graphs, and high-speed exchange between the graph view of your data lake and your Neo4j database instances, which is very exciting for those of you that have large legacy data in Hadoop and similar. You can now treat that as graphs and indeed bring that into Neo4j and operate it on graphs as the laws of nature intended. In the middle of all this, Neo4j 3.4, Cypher's about 70% faster, 5 times or so faster for writes, and we have a bulk importer that's now designed for hundreds of billion scale graphs. We've added date and time data types natively into Neo4j in this release, as well as 3D geospatial search. Multi-clustering is now secure, and we provided security for properties, so those blacklisting of properties. On the right-hand side, we've got the data science things that I mentioned earlier, but we also have this thing called Neo4j Bloom in the visualization part. It's a new graph illustration tool aimed at non-technical users to enable them to explore and edit the graph. It's search-based, it's storyboard-based, and it provides a foundation for data discovery or information discovery, and it's fully integrated with Neo4j. I'll come back to that in a moment, but let me give you a rundown of where you can find these amazing features. So date and time types are both in Community and Enterprise, as are 3D geospatial types. In terms of performance improvements, the native string indexes are in both Community and Enterprise, and the backups, as you would expect, are in Enterprise. The Cypher runtime, the best Cypher runtime is now Neo4j Enterprise Edition, so please do use the Neo4j desktop and grab yourself a dev version of dev license Neo4j Enterprise. And the bulk object importer in Enterprise Edition is now resumable, which is very useful for when you have those occasional blips in import when your network fails momentarily. In terms of admin and scaling, these are all enterprise features. So you've got multi-clustering, cache warming, rolling upgrades, resumable copy and restore of cluster member, a bunch of new diagnostic and support tools, and you've got security by property blacklisting, all in Enterprise Edition there. But I think something that's profoundly exciting for us is that Neo4j 3.4 also marks the point at which we release a brand new product. It's called Neo4j Bloom, and it's in the early access program at the moment. So you can talk to your friendly Neo4j staffer, and they can give you access to this tool. Now, why Neo4j Bloom? Well, you may remember Neo4j is probably, although it's the best graph database in the universe, it also has the worst name in the universe. It's Neo4j. And we're carrying on very much in that vein. So if you remember, this is Neo from the Matrix film. If you're wondering where we got Neo4j Bloom from, well, look, that's Neo. Over there on the fridge, if you zoom in, it says 4j, and if you look over to the right, well, that's Bloom. There you go, Neo4j Bloom. At least we're consistently bad at naming. Oh, thanks, Emil Ephraim, CEO of Neo4j, for giving us that name, by the way. So Bloom is a high-fidelity viz tool which gives you scene navigation, property views, search suggestions, saved phrase history, has a property editor, gives you schema perspectives, all are visualized in this Bloom chart. the idea behind Bloom is that you type Google-ish into the search bar at the top in order to be able to explore your graph. So it's very much aimed at business, line of business users, more than it's aimed at us technical folks. Although as a technical person, I must admit it's rather enjoyable to use this. So Bloom has a prompted search in which you type natural language. You can then edit properties and zoom, pan, and all that kind of stuff, select, and then refine your search visually. And ultimately works like this. So if we were to think about movies, if you wanted to ask questions like the Matrix person also in Cloud Atlas, you type that in and then up comes Hugo Weaving, who was the bad guy in the Matrix and was also in Cloud Atlas. But interestingly, it also finds the directors of the Matrix and Cloud Access, which were the Wachowskis. Fantastic. So simple example, relatively small graph returned, but actually the Bloom visualization engine is refined and well engineered enough so that it can deal with extremely large graphs being returned and still enable you to scan and zoom and pan around them and make sense of them in a way that suits you. So this advances the platform, I think, substantially. This opens up the Neo4j graph platform to a class of users that were previously perhaps put off by having to type cipher. I mean, if you're a technologist, you can imagine that underneath Bloom, yep, there's a lot of cipher, but that abstraction never leaks through to the end user, where the end user is encouraged to ask business-oriented questions about Matrix films or money laundering or trade flows or missions to Mars and so on, and they get data back that reflects those queries. Bloom's a new product. It integrates brilliantly with the graph platform. If you want to try it out, please do drop us a line and we'll get you on the early access program for it. So, quick recap, as Alex promised, just 30 minutes of me howling into the void. But it does mean that we have a few minutes to take Q&A if anyone wants to ask any deeper questions. Thank you.
Thank you very much, Jim. I have one question right from the go. It's, will the index improvements be seen for node key constraints composite indices? From David Hatton. Is that question?
Hello, David. That's an excellent question, and I don't have the benchmarks on my machine right now, but I will take that one offline and get back to you with an accurate answer.
All right. Another question from Joe. Are the data types faster than time trees? It seems they're both using Lucene index.
Yeah, I don't know. I've not benchmarked it against any time trees, so I don't know the answer to that. But I'm going to assume that they are, since both of them are effectively using trees under the covers, it's going to be approximately, or at least algorithmically, equivalent. And I think the advantage of using the date time types is that it means as an end user, I don't have to write a bunch of code to do dates or times anymore, and I can delegate that to the database. So even if they are only equivalent in algorithmic cost, I think I would still use them right now. And given that this has been the one type, apart from decimal, that people have been screaming for like a decade, I think people are going to jump on this very quickly. By the way, I would also point out there that now it's part of the database. You can expect those types to get faster over time as well. So in the long haul, even if you benchmark them today and found them to be broadly the same, in the long haul, it's going to turn out the thing that's directly supported in the database will get quicker.
Cool. Another question from Nicolas Royer. Hi, Jim. If I understand well, you can query Bloom with natural language-like queries. Are there prerequisites on indices and labels?
Salut, Nicolas. Yes, there are some prerequisites on indexes and labels and so on, insofar as Bloom can only reify the data that's in the database. However, in terms of things like full text and so on, Bloom takes care of all of that for you. So from your point of view, if you already have a database which has a rich information model, Bloom should be able to support that for you straight out of the box.
Cool. And maybe one more question from, does version 3.4 now support Prometheus for monitoring? you know?
I'm afraid I don't know the answer to that, Fabian. Sorry. But let me check with my ops team, who are sitting only about 15 meters away from me, and I'll get back to you on that offline.
All right. Cool. Thank you very much, Jim. Thank you very much, everyone, for joining and for questions. And I think that's it for today. Have a good day. Have a good rest of the week. And yeah, see you soon.
Thank you very much, everyone. Bye-bye.